All right, in 3.6, we are going to take a look at graphing rational functions. So in the first part, we're just going to talk about all the properties, and then in the second part, we'll take a look at putting that all together to graph. So first, let's review finding the domain of a rational function. The only values that would be excluded from the domain are any x values that make the denominator equal to 0. So we would want to find those values. So we would just say 3x plus 2 cannot equal 0 and get x by itself. So subtract the 2 over, divide by 3, and we'll get that x cannot equal negative 2/3. So to write my domain, I'm going to write this as the only value that I can't have is negative 2/3. So I'm going to say, well, I'm going from negative infinity up to negative 2/3, not including negative 2/3, union, and then pick back up with negative 2/3 to infinity. All right. Same idea for the second one. Okay, but this time we have a quadratic in the denominator, but same thing. I want to say this quadratic cannot equal 0. So here I can factor, right? If I x factor this, two numbers that multiply to positive 8 that add to negative 6, I think that would be negative 4 and negative 2. So this would factor into x minus 4 and x minus 2. And setting each of those equal to 0, x minus 4. So again, we're saying these can't equal 0 to find these values that we have to exclude. So add the 4 over and we get that x cannot be 4. Add the 2 over and we get that x cannot be 2. So we have two values to exclude this time. And remember, it is important that we write them in order. So the smallest of these is 2. So that's the first value that I will exclude. And this is how my domain would look. Okay, so let's now take a look at some notation for rational functions. All right, first, let's define an asymptote. An asymptote is a vertical or horizontal line that the graph of a function approaches. So I've got an example graph down here. This graph has three asymptotes, one horizontal and two vertical. This horizontal line that these two pieces of the graph approach but never actually reach, we would write the equation of that asymptote as y equals 1. Now, we have two vertical asymptotes here as well that each of these pieces approach but never touch. So the equation of this vertical line, this asymptote, would be x equals 2, and this one would be x equals negative 2. Now, we'll look at a couple examples of this idea in a second, but it is possible for a graph to cross a horizontal asymptote, but it is not possible for a graph to cross a vertical asymptote. All right, so let's look at some notation that we're going to use. This notation here, x with an arrow and then some number with a negative sign that almost looks like an exponent, that means as x approaches that value from the left. So this is kind of like what we talked about with end behavior in the last chapter, where we said, well, as x goes to negative infinity, f of x does what? And as x goes to positive infinity, f of x does what? We're doing similar things here. We're saying as x goes to something, what does my function do? So let's do a couple examples of that. So this first one, as x approaches some number from the left, if there's a negative sign, that means from the left. So this example down here, as x approaches 2 from the left, what that means, okay, so here's my asymptote of 2. That means I want to approach my value of 2 from the left. So from the left would be from this direction. This is to the left of -2, or I'm sorry, of 2. So as I'm approaching +2 from the left, my function is going down. It's going to -infinity. So here, I would say, as x approaches 2 from the left, my function goes to -infinity. Same idea if we have a plus sign, that just means approaching from the right. So here, as x approaches 2 from the right, right? So this is coming from the right, my function is going to +infinity, right? As I'm approaching from the right, my function is going up, right? It's going to +infinity. We can do the same thing here for my asymptote at x equals -2. So as I approach -2 from the right, so from the right would be from here, I'm going to -infinity. As I approach -2 from the left, I'm going to +infinity. And now we can also talk about essentially end behaviors, right? As x goes to -infinity and as x goes to +infinity, what happens? So as x goes forever to the left, we are approaching this y value of 1. We're never actually going to reach it, but we still say that's what we are approaching. As x goes to -infinity, f of x is approaching 1. And as x goes to +infinity, we are also approaching that y value of 1. We get closer and closer and closer, even though we never actually reach it. Okay, so these are very closely related to our ideas of end behavior from the last chapter, but just a little bit extra notation. If we have a plus sign up here, that means from the right. And if we have a minus sign, that means from the left. Okay, so now let's take a look at finding vertical asymptotes, right, from an equation or algebraically. So what we first want to do is factor both the numerator and denominator and cancel any common factors. Then after I've canceled any common factors, then I'll set the denominator equal to 0 and solve. These will be the equations of the vertical asymptotes. Now, an important note, okay, if we are able to cancel any common factors here in step 1, that creates a hole in the graph. So let me show you an example of that. Okay, this function here, x plus 2 times x minus 3 over x minus 1 times x minus 3, I could cancel out these factors, right? The x minus 3 and the x minus 3. If I am able to cancel out a set of factors, I'm just going to graph whatever's left. So in this example, this red line, this red curve is just x plus 2 over x minus 1. But one extra thing that happens is I have a hole then right here at x equals 3. Okay, the graph isn't defined at that single point. So if I'm able to cancel out common factors, I would graph whatever's left, but I need to make sure I include a hole at that specific x value. So let's look at a few examples and find either asymptotes or holes. So first step, factor numerator and denominator, right? So the denominator here factors, the numerator does not, obviously. This is a difference of squares, so this would just factor into x plus 5 and x minus 5. Can't cancel anything out, but now I can set the denominator equal to 0. So x plus 5 equals 0, and x minus 5 equals 0. Right? Whatever factors we have, we'll set those both equal to 0, and subtract the 5 over, we'll get x equals -5, add 5 over, and we'll get x equals 5. So this graph would end up having 2 vertical asymptotes and no holes. Now, usually we abbreviate vertical asymptotes just VA. So we can say VA are x equals -5 and x equals +5. All right. In our next example, again, I can't factor the numerator, and I actually cannot factor the denominator here either. We can only factor a difference of squares, not a sum of squares. So let's set the denominator equal to 0 then. So x squared plus 1 equals 0. Subtract 1 over, take the square root, and the square root of -1 would actually just be plus or minus I. So what that means, since I did not get any real numbers, that means that there are no vertical asymptotes. We didn't find any holes either. So we can just say no VA, right? No vertical asymptotes for this example. In the next one, again, we want to factor everything we can. So this difference of squares would become x plus 3 and x minus 3. Now I can cancel out these x minus 3's. And I would just be left with 1 over x plus 3. So what that means, let's make a note before we forget, that there is a hole at x equals 3. Right? Again, we would want to think about setting this equal to 0 and solving. Now, we can set the denominator equal to 0 to find vertical asymptotes. So just subtract the 3 over and we'll get x equals -3. So in this example, we have a hole and a vertical asymptote. Okay, let's do one more example here. So on this one, we want to factor both the numerator and denominator. So x squared minus 6x plus 8, we actually did that in an earlier example already. That would factor into x plus 4 and x plus 2. And my denominator here, two numbers that multiply to -12 that add to -1, I think we could make that x minus 4 and x plus 3. All right, so in this example, none of my factors cancel. So set my two factors in the denominator equal to 0. Add 4 over, subtract 3, and we get 2 vertical asymptotes. All right. Now, let's take a look at horizontal asymptotes. There's 3 situations that could occur. Okay, if the degree of the top is less than the bottom, right, or the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. So an example of something like this, where the degree of the numerator is less, we could have something like, x over x squared minus 3. Right? The degree of the numerator is less than the degree of the denominator. The horizontal asymptote will always be y equals 0. Second possibility is if the degrees are the same. So here, if we've got the degrees the same, and again, let's write down an example as we're talking about this. So we could have something like y equals 2x cubed minus 4 over 7x cubed plus x, right, where the degrees are the exact same. Then the horizontal asymptote is y equals leading coefficient of the numerator over leading coefficient of the denominator. So for this example, my horizontal asymptote would be the line y equals 2 over 7, y equals 2/7. Okay? If the degrees are the same, the equation is y equals leading coefficient over leading coefficient. Then the final possibility is if the degree of the numerator is greater than the degree of the denominator. In that case, there is no horizontal asymptote. So again, an example of something like that could be y equals x squared over x plus 6, right? Where the degree of the numerator is greater than that of the denominator. Now, we already mentioned this, but unlike vertical asymptotes, the graph can cross a horizontal asymptote. And we'll look at graphing these in the next section, but just remember that. So an example of a picture of something like that would be this. This is the equation 5x plus 2 over x squared, where y equals 0 would be my horizontal asymptote because the degree of the numerator is less than the degree of the denominator. But notice this piece of the graph crosses that asymptote right there. And then as we go to negative infinity, it won't cross it again. But it is possible for a graph to cross horizontal asymptotes. All right. So let's look at a couple of examples and find horizontal asymptotes. So in this first example, 4x over x squared plus 1, the degree of the numerator is less than the degree of the denominator. So my horizontal asymptote, which we abbreviate HA, would just be y equals 0. Right? In my second example, the degree of the numerator is greater than the degree of the denominator. That means there is no horizontal asymptote, or no HA. And then my third example here, my degrees are the same. Second degree, second degree. That means that my horizontal asymptote is leading coefficient over leading coefficient. So my horizontal asymptote here would just be y equals (3 over 5). All right, so let's look at one final example where we are finding both the horizontal and vertical asymptotes. Okay, so let's start with vertical. Right? Well, to do that, we want to factor both the numerator and denominator. Okay, so let me come off to the side here, and let's factor 2x squared minus x plus 4. So whenever my leading coefficient is not 1 in a quadratic, we'll have to factor by grouping, right? So in this case, we're looking for two numbers that multiply to 8, that add to -1. Well, I don't think there are any, right? No factors of +8 that would add to -1. So in this case, I don't think that my numerator is factorable. Right? So we can skip that first step and just go on to factoring the denominator. So the denominator would factor into x plus 3 and x minus 3. So those are the factors that I would set equal to 0 to find my vertical asymptotes. So this would give me a vertical asymptote of, sorry about that, of x minus 3, or I'm sorry, x equals -3, and this one would give me a vertical asymptote of x equals positive 3. All right, so I can write my VA here. Two vertical asymptotes. And then my horizontal asymptote, in this case, the degree of the numerator and the degree of the denominator are the same. They're both squared, which means my horizontal asymptote is y equals leading coefficient over leading coefficient. So that would be 2 over 1, or just 2. So my horizontal asymptote here is y equals 2. All right, that is it for this video. The final question is going to pop up asking you what questions you have.